So we've just finished talking about all the different parts of the ocean floor, and now we're going to move into what lives there. When talking about ocean life, we can group them into three main categories. The first one is plankton. Plankton are any organisms that float or drift near the surface. These organisms can't move themselves like other organisms can. They don't have fins or flippers, so they can't move at their own free will. They depend upon the waves and the currents to move them around. And there are two types of plankton, and you see them here. Plankton can either be plant-like, those are called phytoplankton, or they can be animal-like and called zooplankton. The second kind of organism is called nekton. These are organisms that can swim in the ocean. So these are what you typically think of when you think of ocean animals: fish, sharks, whales, dolphins, sea turtles, sea lions. These are organisms that can move independently and go where they want to. The last kind of organisms are called benthos. These are organisms that live on or in the ocean floor. An easy way to remember this is that they live on the bottom. Benthos are in the bottom. And so these organisms don't swim freely through the water. Most of the time they crawl around on the ocean floor, or they're a type of plant that grow out of the ocean floor. So some examples of those would be crabs, starfish, worms, corals, sponges, seaweeds, and clams. Now, out of the whole ocean, we can divide it into two parts. They are listed on your screen here, either the benthic or the pelagic. An easy way to remember this is the two parts of the ocean being either the bottom, or like the sand, or the water. So the benthic is all the ocean floor and the organisms that live in it. You will recognize this from what we just talked about, those benthos organisms that live on the bottom. So benthic is the bottom environment of the ocean. Now that can be the bottom of a continental shelf where it's shallow, but it could also be the bottom of the abyssal plain and even into the trenches where it's deep. The pelagic refers to the water. So this is all the water in the ocean, the water that could be in the shallow area of the shelf or water down deep in the trenches. And because the ocean's so big, we see certain things happening in terms of the pelagic or the water environment. Starting at the top of the water, of course, it's closest to the sunlight. So sunlight can penetrate the water, and it keeps the water fairly warm. And a lot of things can live here because they depend on the sunlight. But as you start moving down in the water, you'll notice the sunlight decreases, so it's getting darker. You'll notice the temperature is decreasing, the water's getting colder, and you're going to notice the amount of life decreases because things have a hard time living without the sunlight. But the one thing that's going to increase, of course, is the pressure. And if you'll remember from when we talked about the layers of the earth, as you go further down in the earth, the pressure increases. The same thing is true in the ocean. As you go down into the ocean, the deepest parts, the pressure increases because you have more water pushing down above you. Remember this human pyramid? We're looking at it again because it's the same idea. The person at the top of the pyramid is going to represent the top of the ocean. So there's not much pressure there because no one's pushing down above them. The row of people on the bottom would represent the bottom of the ocean, therefore they would have the greatest pressure.
To see some things that live in the ocean, the Phoenix drags a net along the bottom of Long Island Sound.
Oh, let me hear you! Better!
The students then help pull in the net.
Let's start off with this guy. He's the most familiar.
Horseshoe
crab. Okay, everybody agrees? Horseshoe crab?
Yeah.
This animal's got two names, okay? Horseshoe crab, it's also known as a king crab. Okay?
Why is it called king?
It's just another name they've given it. I don't know, because they get pretty big, maybe. And the tail, there's no stinger on the tail or anything. But say you were to be walking along the bottom, you'd accidentally step on him. Look at these burrs on his carapace. See all these burrs? That would feel like a sting, wouldn't it?
Yeah.
Also on the tail, look how the burrs go up. See how they're all oriented in one way? So if you were to step down, you would end up with a nice laceration on your leg.
Horseshoe crabs and all other kinds of animals that live on the ocean bottom are members of a group called benthos. The bottom is called the benthic layer of the ocean. Another group of marine organisms are called nekton. These swim freely through the water. Among the nekton are thousands of different species of fish, sea turtles, and mammals like whales and dolphin.
A third group that lives in the oceans are plankton, living things that simply float or drift wherever the waves or currents take them. Many kinds of plankton are plants and animals too small to be seen by the naked eye. But they can be gathered using special plankton nets. This jar of water contains thousands of plankton. With the help of a microscope, you can see an incredible diversity of these tiny ocean dwellers. Some are called phytoplankton. Phytoplankton are plant plankton. The most abundant are diatoms, whose unusual shapes come from the glass-like boxes in which their cells are encased. Looking like Christmas ornaments, diatoms come in a variety of shapes. Phytoplankton get their green color from structures inside their cells called chloroplasts. Chloroplasts are responsible for photosynthesis, the process through which plants produce oxygen. Phytoplankton produce more oxygen than all the Earth's trees and forests combined. In fact, over half the oxygen in the Earth's atmosphere was made by phytoplankton floating on or near the surface of the oceans. Phytoplankton are important for other reasons. They are the main food for animal plankton or zooplankton. The zooplankton, in turn, are eaten by many other kinds of marine animals, from tiny fish to baleen whales. Without plankton, most kinds of marine life would starve and become extinct.
Plankton and most other kinds of marine life exist in the top layer of the water, within a few meters of its surface. This layer gets the most light and heat from the sun. But light from the sun's rays decreases rapidly as you go deeper into the ocean water. Most of the ocean, in fact, is totally dark. As you descend into the ocean, the water temperature also becomes colder. And there's another change that occurs the deeper into the ocean you go. The pressure of the water increases rapidly with depth.
A simple experiment demonstrates the effects of water depth on pressure. Poke 3 holes in the side of a milk carton, one near the top, one halfway down, and the third near the bottom. Fill the carton with water and observe the streams of water that escape. The stream at the bottom is the strongest because there is greater water pressure at the bottom of the carton than at the top. Pressure is measured in pounds per square inch. Standing on land at sea level, each square inch of a person's body is being pressed by about 15 pounds of air. At 5 meters, or about 16 feet below the ocean surface, the pressure from the weight of the water is much greater, enough to make a diver's ears begin to hurt. Scuba divers can swim to depths of only about 75 meters, or about 245 feet. Beyond this depth, the pressure would squeeze against the divers so hard that it would be difficult for them to breathe. Most submarines dive to only 465 meters, or about 1,500 feet. Much beyond this depth, the pressure would be great enough to crush a submarine's hull.
There are, however, special submarines called submersibles that are designed to resist great pressure. This is the Alvin, owned and operated by the Woods Hole Oceanographic Institution in Massachusetts. The Alvin is used to explore to depths as great as 4,000 meters, over 13,000 feet. Submersibles like the Alvin have allowed humans to explore areas of the ocean depths that were previously unreachable. One of the things they found is that even here life exists, like this lanternfish, whose soft, flexible skeleton can resist great pressure. Like many deep-water fish, the lanternfish is bioluminescent, which means that its body contains chemicals that give off light.
The flatness of the ocean surface is broken only by waves, but the surface disguises features that are as diverse as those found on land. Scientists have been able to map the ocean bottom using sonar. A sonar device on a ship sends sound waves through the water. These sound waves bounce off the ocean bottom and back to the boat. By measuring how long it takes for the sound waves to return, researchers can tell how deep the ocean is. Satellites provide another way to study the ocean bottom. Using computers, scientists can analyze measurements made by satellites of the height of the ocean surface. These measurements indicate bumps on the surface caused by mountains on the sea floor. Valleys and canyons, on the other hand, cause slight depressions on the ocean surface. Using information from satellites and sonar soundings, researchers have drawn maps of the ocean bottom. This computer-generated image shows what the Earth would look like if its oceans were drained of water.
The part of the ocean floor with which we are the most familiar is the continental shelf. The continental shelf is part of a continent that is underwater. It extends out from the shore in a gentle slope. This is one part of the ocean that you can partly explore on foot by wading out into the water, as these students are doing at Carmsett State Park on Long Island. Along the continental shelf, there is an abundance of sea life, for here the water is shallow and gets a lot of light. By dragging a net carefully through the water, you can see some of the kinds of marine life that live close to shore.
All right, you want to get the fish in the bucket as quick as possible, otherwise they might not live.
The catch here includes tiny hermit crabs and baby flounder.
At the end of the continental shelf, the ocean bottom drops off sharply. This part is called the continental slope. Beyond the slope are large flat areas of the ocean floor that are called the abyssal plain. However, in some places, particularly the Pacific, the continental slope ends in a deep trench. Scientists believe that the Earth's surface is made up of large plates or sections of rock that are constantly moving. Trenches are formed when two plates collide and one moves under the other. Some trenches are thousands of kilometers long and are the deepest places in the oceans. The deepest trench of all is the Marianas Trench in the western Pacific. In places, it reaches a depth of more than 11,000 meters, or about 36,000 feet below the ocean surface. From its lip to its bottom, the Marianas Trench is several times deeper than the Grand Canyon.
Along the ocean bottom, there are also long mountain ranges called mid-ocean ridges. The Mid-Atlantic Ridge stretches down the middle of the Atlantic Ocean and is only one part of a ridge that winds its way around the Earth. Ridges are formed where two ocean plates are moving apart. Here, magma, or hot liquid rock, from deep within the Earth, seeps out between the plates and then cools to form new crust. Near mid-ocean ridges, the Alvin has found hydrothermal vents,